Welcome back to the course Sustainability through Green Manufacturing and Applied Approach. So, this is week 3, lecture 4, and I am Dr. Amandeep Singh. So, till now, what is covered in this course, Dr. Deepu Philip has introduced the sustainability framework to you, and the systems approach was taught, and also he went through certain simulation techniques and like how to conduct simulation analysis for sustainable environment, and certain other concepts of facility and unit manufacturing process and flow line, those all were discussed. And I took life cycle assessment. Life cycle assessment will continue in this lecture as well. I'll start with an example here. So, in this session I'll cover materials flow and we'll then discuss what are benefits of LCA, or what is your takeaway from learning life cycle assessment. Then we'll take an example of automobile LCA. Right. So, I will start with this one. This is known as Ryco Comet Circle. Ryco is a company that manufactures printers and some other electrical and electronic stationery instruments like paper shredders, printers and products like that, right. Ryco came up with this comet circle in which they represent the various flow of the material from the user. Why the word comet is used here? Actually, what is comet? Comet is an heavenly body that revolves around the sun. The orbit of the comet is like this one. This is sun, and the comet has an orbit like this, and elliptical orbit is this, right. And comets have tails like this. If it is traveling, the trails will be pointing away from the sun, right. These comets has tails. So, this is actually one comet, this is why this it is a tail for this one. So, finally, what happens if when comet it is keep on coming closer to the sun here, right. Then one day this comet has to vanish. There is a life for the comet, maybe from hundreds to thousands of years. This is the life of the comet, and finally it totally vanish, right. So, this concept of comet revolving around the sun is used to explain the degree of impact at each stage of the product, right. For example, this is a user here, right, and user gets his product he purchase maintained by the company, that he gets a after sales service, and he kept on getting the maintenance and repair and keep on using that for long time. For example, I took the example of bikes in life cycle costing. You purchase the bike, right, then you keep on getting it maintained. That's the service, what the first service you did, the company asked to do it in first 2500 kilometers, then in 5000 kilometers, then every 2500 kilometers, or in 3 months, maybe in 6 months you get it serviced. So, this is known as preventive maintenance. That is prevention of any breakdown or stopping of bike, right. So, this is preventive maintenance, you keep on getting it through the company. Then next is even corrective maintenance is there, sometimes you do that. Corrective maintenance is what? When some small issue come up in the bike. For example, your bike brakes stop working, or the brakes are not working well, or your clutch plates got deteriorated, your kick is slipping, right. Then what you get that part replaced. That is your corrective maintenance. And sometimes it happens that your bike totally stops moving, right. some part is totally breakdown, that is known as breakdown maintenance. So, these kind of maintenance the customers keep on doing and keep using the product, right. Now, the second comment circle is the product when you sell is collected by the collection center, like they purchase second hand bikes, they do some maintenance and give it to the second hand user. So, in this case what they are doing, they are repairing their bike or maybe engine overhauling and a product is recovered here, right, engine overhauling or maybe some components are changed and the sales company would again send to another users who would like to purchase a used bike, right. Then third stage or circle here is when the product is sent to recycling center. Now, what does this recycling center do? They sort and disassemble various kinds of parts in our product and they differentiate into various categories. For example, plastic products, rubber products and not products, sorry, components here, and metal components, different types of metals. Then if in aluminum, if I say like carburetor or pistons are hard aluminum, they are melted at a little high temperature, and various other kinds of products like steel, aluminum, manganese, all these things, manganese in electronics equipment, right. So, these are all segregated and they send it to part recovery center, who could reuse the parts and it is sent to sales company. Sales company can use this as spare parts. That are reusable. So, the next is the parts are sent to the shredder company. This is next cycle here. The shredder company totally crushes the products, they shred it into pieces and extract the components, I would say not components, they convert it into total landfillable position, right. Shredder company would send some of the portion to material recovery company. Material recovery company can again send to the parts manufacturer here, right. Parts manufacturer could again send to product manufacturer, which could again go to sales and the user. So, some of the parts the user of recycling materials use some of the parts here. For example, recycled plastic is used, is generally purchased by customers at lower cost. Recycled plastics have certain bad effects induced into them. For example, the plastics become smelly after some time, and in food grade plastics it is never recycled. That is for dustbins or bins or the dry things where we have only that, and in those places recycled plastics could be used. So, the next is the shredder company sent it to the oil recovery company or smelting company, right, who would send it to the materials manufacturer. This is now materials processing. Right, actually this is raw material processing only. They could even extract some thermal energy from this oil and generation of certain raw materials like chemical recycling, metal recycling, that happens. Then energy recovery is here, and finally we have disposal. So, this case is the worst case. Worst case, or I will not say case here, I would even add here stage when it goes to landfill. So, the purpose of sustainable approach here is to keep this comet circle smaller. The more we are towards the left side, or more small is the circle, or like would say smaller is the size of this comet circle or this part, this is more sustainable. This, for example, I would say if I grade it, or if I like to give them colors, I would give this as green color, this as orange color, and the last one as this one as red color. Okay. So, this is how the material flow happens. So, it could have been noticed here that all the players, all the stakeholders from manufacturers, suppliers, customers, then customers, who is left here, the recycling companies, I would say recyclers, they all participate in this to reduce the degree of impact at each stage, and they all have partnership, right. They need to have partnership to have better product, right. It is with respect to greenness. So, here at the smaller comet circle, even the economic value or the value of the product is higher. Here the value of the product is higher, and as we move toward this side, the value becomes lower. This is value, right. And reuse can be by the customer only or maybe by the manufacturer, and recycle is a this recycling is a multi-tiered recycling system. Reused is actually inner loops here, after that only recycles happen, and they need to establish partnership at each stage, and the dealing with the systems approach here is important. This understanding of the material flow would help us to conduct life cycle assessment in a better way. Now, I would come to certain takeaway from life cycle, from LCA information that is being shared. So, what is LCA? Or what are the benefits, I would say, what are benefits of PCA? LCA helps in environmental labeling, like we have star rating, then we have certain eco labeling on the product, right. Then LCA helps in product environment improvement. Then we can even have eco design with LCA, then maybe policy evaluation, so this is what LCA helps us to do. Next, I will come up with an example of automobile manufacturing and discuss LCA that was conducted by in a study for an automobile manufacturing. So, before that, I like to explain this illustration that is brought from an reference here, a reference from 2009. In this case, what we are showing the embodied energy for a car, for manufacturing a car, right. So, what it is showing that a car embodied energy is about this much, 76,000 kilowatt hour, depending on where it is manufactured, he is saying. Now, we have various quality of energy here. This is how electricity is produced. So, it depends upon how electricity is produced, right. So, in France, it is 83 gram of carbon dioxide that is produced to produce 1 kilowatt hour of electricity, right. So, it becomes 0.001 megaton per megawatt hour. So, we multiply energy that is used for car into this, it becomes this much of carbon dioxide is produced to manufacture a car in France, and we can see the condition of India here. So why is this difference here? Because the energy they are producing, the electricity power they are producing is from different sources. These the countries, the clean countries, the countries who are working on this clean technology produce it from nuclear energy, nuclear, right? And in India we use thermal plants primarily, right, which use coal. That is why the pollution level is this much high. And if I say, if I even say that this much 7600 kilowatt hour of energy is embodied in car that is manufactured in India, the this value of the carbon dioxide value that is produced would come close to 650 megaton. Right. So this is what I am talking about, the quality of energy here. I would like to tell you one more concept here, that is energy ladder. What is energy ladder? Energy ladder tells us the quality of energy based on its cost or cleanliness or the kind of fuels we are using. So this is a ladder, it helps us to climb up, right? So what we have here on this side, it is cleanliness, right? And the most clean energy is renewable energy, solar energy or maybe wind energy, right? Then we have electric energy, right? Then how is this electric energy produced? That is another factor, like I told about nuclear, then maybe hydel power plants, maybe thermal power plants. So in this case also the quality is going down here. So then we have gas, then maybe kerosene, then comes coal, then wood, or then comes down what is used in the rural areas, or in India maybe the crop or animal dung. Oh, this is the energy ladder. These are the primitive fuels here. Primitive fuels, right? And these are transition fuels. Transition means they helps to produce our the better or advanced fuels, I would say. Advanced energy, right? I would like to share one more thing here, like moving back to that example which we shared regarding the diaper selection. So in that case, what we found that laundering was the process that was deteriorating the environment very badly. So in laundering, we also dry the clothes. Like the industrial laundering people also dry the clothes. In home also there are various kinds of dryers. The dryers use electricity, like the spinner is there that rotates and dry the clothes. In some of the machines even heater is available. So what we are using electricity to dry the clothes. So this is not a good idea with respect to our sustainability approach. It is better to use solar energy or wind energy to dry the clothes than to use electricity. So this is called reduce. So if you could recall this approach regarding before disposal we could recycle, reuse and reduce the use, reduce the consumption. So, in this case this solar energy would reduce our consumption. Also we had refuse here, right. So, what we are talking about here is the energy that is embodied in manufacturing a car in India we are talking about. So, we are concerned here about the quality of energy, right, energy quality, and also we need to reduce this energy. So, what is happening in these days, while the use of the car by end user I am talking about here, by end use, right. So, the kinds of fuel that we are thinking about to use in future are clean fuels, right. We have clean fuels here, like presently we have gasoline fuel, and the cars, the concept is there, even testing is done. The only thing is that mass production is not there. Micro hybrid cars. What are these micro hybrid cars? They switch the gas engine off when the vehicle would normally be idling, running the mechanical such as heater, batteries, etc. Efficiency gains are from 5 to 10% in this case. Then we have mild hybrid cars. Now, mild hybrid cars stop the engine during the idling and provide additional power from electric motor during acceleration. The efficiency gain here increases from 10 to 20%. Then we have full hybrid cars. Now, full hybrid cars run completely on electricity, completely on electrical power. So, in this case from gasoline we are going to electric power, that is on battery, right. Now, full hybrid cars run totally on that, and efficiency gain is from 25 to 40% here, and there are also plug-in hybrids. So, plug-in hybrids run the car solely on electric power for first maybe 50 to 80 kilometers, then the function like full hybrids, like full hybrids car function, right. So, unlike the others, they have to be unplugged or they need to be unplugged and then plugged into the recharge. The efficiency gain here increases from 40 to 60%. So, if we could recall the various stages of material flow, those were material extraction, material processing, then actual manufacturing, end use and disposal. Okay, the material flow happens from the very first step and keep to the final disposal here. So, this study was conducted in 1990, in which the weight of the material flow was considered as a criteria, right. So, in this the weights, the kind of material that was considered was steel, plastics, and rest materials were there like aluminium, copper, zinc. I will put this as miscellaneous, right. Now, I have total weight here, I will try to make a table here, right. So, we have raw material input into this and loss coming out, raw material, and loss is, that is the waste that is produced. And also in end use we have waste and reuse, the weight that is transferred here. And after end use we have some of material even going back to the processing here. So what was observed in this study, that the total weight of the automobile here was 1366. This is kgs, kilogram, all weights are in kilogram, right. So total raw material that entered into this stage, into material extraction, was 1306 kg, out of which the loss during this raw material extraction process was 128 kg. So material that went into material processing was this difference, 1366 minus 128, that is 1238. And in material processing we also had loss, at all the stages we had loss, and in this final disposal stage we had landfill, and recycle. Now in this case the loss was 80 kg of the weight. The weight that entered into the next stage would be 238 minus 80 kg, and please note some weight is coming from end use as well. So this weight I would put a different color here. So this weight is plus 110. So the weight that entered into this stage, so the weight that entered into manufacturing stage was 1268 kgs, right, out of which 29 kg is the loss, and we are left with 1239 kgs, right. So the thing is that why I am talking about the kilogram or the weight flow here in material flow, the weight of the material. This is also one of the way to conduct life cycle assessment. If we know what is the loss or how much is the weight of the material that is being transferred to the next process, and what is the energy that is required to produce per unit of this material, per unit of steel, per unit of the specific plastics. The plastics that are being used here are PVC, polyvinyl chloride, polyurethane, and some polyesters, right. The miscellaneous materials are aluminium, copper, zinc. So how much of energy is required to produce 1 kg of this one? So at each stage we could do assessment that at what point the loss is higher, or what kind of material is having higher loss, and the kind of the weight of the material multiplied by the energy that is required to be the produce 1 kg of that material would be the criteria here, right. So this was 1239. So in this case reuse and waste were 80 kgs and 92 kgs, and final disposal of the product, when it happened, it was 987. Now this guy who conducted this study in 1990, his name is Gilley, Douglas Gilley, and he is from US. He actually observed these weights in the factory. And finally the recycling that was done was about 700 and 63 kg and remaining 264 kg were landfill. So, in this it was even segregated what kind of material had what kind of weight. So, in case of steel the weight was of the order of 1026 and in case of plastics it was of order of 107 kgs and miscellaneous was 136 kgs. So, they had certain values here as well and final disposal was also there. So, this kind of study can also be conducted to conduct life cycle assessment. Now, in this case this is the total weight of the car, that is input, and this was the in the disposal stage, this is the landfill here. So, what is the landfill impact here, right? This is actually weight. So, what is the volume for this material, for volume for steel, volume for plastic, then volume for miscellaneous materials to do the landfill. This is one of the parameter here, and what is the embodied energy to produce this material, and at each stage this much loss is there. So, what is energy associated with this one? So, this is one of the case. So, for more details you can read this study by Douglas Gilney that is present online, right. And in the concluding weeks of this course we will take the soft tools as well, how to conduct life cycle assessment using soft tools, and also we will conduct simulation analysis using soft tools. Thank you.